In this video, we'll see how to determine forces in cables by applying the conditions of equilibrium. The horizontal force that is acting is 300 Newton and mass is 20 kg. Now, first we'll determine the angle that is made by these cables A, B and AC which are supporting this mass of 20 kg. So suppose theta 1 is the angle that is made by the cable AB with the horizontal. So we'll draw the right angle triangle ADB over here. So the vertical distance is of 1 meter and horizontal distance is of 2 meter. Then tan theta 1 will be equal to opposite side divided by adjacent side. So it is 1 upon 2. That is theta 1 will be equal to tan inverse of 1 upon 2, that is 26.565 degree. Similarly, we will calculate the angle made by this cable AC with the horizontal, that is theta 2. So we'll draw the right angle triangle A, D and C. So total distance from D to C is 1 plus 1.5, that is 2.5 meter, and the horizontal distance AD is 2 meter. So that is shown over here. So tan theta 2 will be equal to, again, opposite side divided by adjacent side. So theta 2 will be equal to tan inverse of 2.5 divided by 2, that is 51.34. So now it will become easy for us to draw the free body diagram and then to resolve the forces in x and y direction. So let us draw the free body diagram over here. So weight is always acting in the vertically downward direction. So W is equal to mg, mass is 20 kg. So 20 into g is gravitation acceleration, that is 9.81. So it is 196.2 Newton. So weight is W, that is acting in the downward direction. Horizontal force of 300 Newton is shown over here. Then tension in cable AB is TAB and tension in cable AC is TAC. So using this, we'll resolve the forces TAB and TAC into its x and y component. So adjacent to the angle is the cos component and opposite to it is the sin component. So this is TAB cos theta 1 and the vertical component is TAB sin theta 1. Similarly, here it is TAC, that is this force is TAC cos theta 2 and this is TAC sin theta 2. And the horizontal force is of 300 Newton and vertical force is of 196.2 Newton at point A. So let us start with the conditions of equilibrium. So first condition that will apply is summation of forces in x direction is equal to 0. Forces towards right, they are considered as positive, whereas forces towards left, they are considered as negative. So simultaneously we will see these two diagrams along with these horizontal and vertical forces. So first one is the horizontal force that we have to take into consideration. So TAB cos theta 1 is negative because it is in the negative x direction. TAC cos theta 2, it is also negative, but 300 Newton is the positive because it is acting in the positive x direction. So if you take minus sign common, then these two minus sign they will become plus and this plus will become minus, or you can say that transfer this minus sign will get cancelled with 0 and transfer this negative 300 on the other side, it will become positive. So our first equation is TAB cos theta 1 plus TAC cos theta 2 is equal to 300. Similarly, we'll apply the another condition of equilibrium, that is summation of forces in y direction is equal to 0. Upward forces positive and downward forces negative. So again, you can see TAB sin theta 1, it is acting in the positive y direction upward, so it is positive. TAC sin theta 2, it is also acting in the upward direction, so it is positive. So upward forces are considered as positive, whereas this W, it is acting in the downward direction, so it is negative. So we can say that the equation will be TAB sin theta 1 plus TAC sin theta 2 minus W is equal to 0. Now transfer this minus W on the other side, it will become positive. So now we are having two equations and two unknown. So TAB and TAC we have to find out. So first we'll write down these two equations. Now solving these two equations, substitute the values of theta 1 and theta 2 over here. So our third and fourth equation will be, in place of theta 1 substitute 26.565 which we have already calculated. In place of theta 2 substitute 51.34 and we'll get these two equations, they are modified and will get converted to equations 3 and 4. And solving this simultaneously on your calculator will get the values of TAB as 266.537 Newton and TAC as 98.609 Newton. So in this way, we can find out the forces in cables by applying the conditions of equilibrium in statics of engineering mechanics. Thank you very much for watching.